P is a positive constant. Find the area enclosed between these two curves. Well, I'm going to start by drawing the square root one. Okay, it's just a stretch in y direction by factor p of the square root function. So it's going to still look like the square root function, a little bit like that. So y equals p x to the half. And then x equals p root y is going to be very similar, but instead of sort of going up and along and sort of becoming less steep along the x-axis, it's going to do exactly the same, but along the y-axis. So actually it will look like that. And if you're not convinced, well, what you can do is square it. We get x squared equals p squared y. So y is equal to x squared over p squared. You can see I get a quadratic. It does look like a quadratic. And really the thing to take out of this is when you have y equals root x, and if you're ever struggling to remember what it looks like, just remember it's really the quadratic x equals y squared, just without the negative part. But that would be a perfect parabola. Right, now, another good reason for making it y equals is that it's going to make the integration a little bit easier in a minute. You can actually integrate along the y-axis. That's something that's covered in further maths, but for our purposes here, I'm going to stick to normal integration along the x-axis. Let's find out where it intersects because then I can integrate, because I'm trying to find the area enclosed, which is this bit here. So I'm going to be integrating the blue curve between 0 and whatever that point is, then the red curve and subtracting. So I need to solve x squared over p squared equals p x to the half. And that means I can divide through by x to the half. I'll get x to the 3 over 2. And that will equal p to the 3. And then I could take the cube root at this point if I wanted to. So I get x to the half, because that is x to the half all cubed. X to the half will equal p. And I'm going to square. So x is equal to p squared. Right. That point there is p squared. So my area enclosed is going to be, let me do it all in one go. It's going to be the integral from 0 to p squared of p x to the half. That gives me all of this bit minus this bit here, minus x squared over p squared. So I'll get x to the 3 over 2, and then 2/3 p, and then 1/3 or 1 over 3 p squared, maybe I'll write it as x cubed. Evaluated between 0 and p squared. Sub in for x equals p squared, so 2/3 p times p squared to the 3 over 2. Well, that's going to be p times p cubed minus 1 over 3 p squared times p to the 6. And then when I put the 0 in, I'll get 0. Okay, we're nearly there. 2/3 p to the 4 minus 1/3 p to the 4, because this cancels partially with this, which will leave me with an answer of 1/3 p to the 4, or p to the 4 over 3, which gives us d as our answer. Nicely done.